Hello, let's see the error probability in QPSK. The received signal in an AWGN channel is represented by this equation: x of t is equal to the transmitted signal plus the noise. Now this noise is a Gaussian noise process with mean 0 and variance n0 by 2. And the observation vector, you have two bases in QPSK, phi1 and phi2. Phi1 is cos and phi2 is sine. So you will have two elements in the observation vector. Okay, so this is your observation vector where x1 is this and x2 is this. Okay, this is plus or minus root e by 2. Okay, w1 w2, where w1 is integral 0 to t w of t phi1 of t. That is, w1 is integral 0 to t w of t phi1 of t dt, and w2 is integral 0 to t w of t phi2 of t dt. And we have seen the signal space or the constellation diagram of QPSK as this. You have four symbols to transmit M1 to M4. Now a better decision boundary will be like this. Okay, so this is Z1 region, this is Z2, Z3 and Z4. If your received signal X falls in the region Z1, it will be taken as the message 1, and if it falls here in the region Z2, it will be taken as M2. Okay, if there was no noise, you will be sent, suppose you had sent M1 and there was no noise, then you will be receiving the same point here. You transmitted M3 and if there is no noise, you will be receiving the same point. But since there is a noise, you had transmitted M3 and the M3 will not be here always. It may be somewhere here or here or here, and some cases it can be here as well. Okay, so the most appropriate decision strategy may be like this: anything falls here in Z3 will be taken as M3 and here M4. Now I had transmitted M3, but the received signal is somewhere here because of high noise, then this will be taken as M4, and that is an erroneous decision. What is the probability of such erroneous decisions? Say I had transmitted symbol 1, but because of the noise I received a point somewhere here or here or here. Okay, so what is the probability of such erroneous decisions? And in the previous lecture we have seen that QPSK is simply two BPSK signals added together. Okay, this is a in phase BPSK and this is quadri phase BPSK. Now see x1. Okay, x1 is this. Okay, x1 is simply plus or minus root e by 2 plus w1. x2 is plus or minus root e by 2 w. And x1 and x2 have mean is equal to root e by 2 and variance n0 by 2. Now compare this with BPSK. In BPSK you had x1 is equal to this, plus or minus root eb plus w1. There you have mean is equal to root eb and variance n0 by 2. Compare this with this x1, that is this BPSK channel. Here you have root eb by 2, here you have root e by 2, and w1, again w1 here. Mean is root e by 2, here mean is root eb, variance is same. With this setting you have probability of error in BPSK is equal to half complementary error function root eb by n0. Here you had root eb, okay, instead of that you have root e by 2 here. So here you have root eb, here you have root e by 2. So the error probability of this channel will be, in phase channel will be half error function, instead of EB, simply substitute E by 2 N0 and you will get this. Let that be P dash. Then the probability of error in the quadriphase BPSK will also be the same. Okay. So you have two channels, in phase channel BPSK channel, quadriphase BPSK channel. Each have a probability of error which is equal to this or P dash. Now, what is the probability of correct decision in phase channel? The probability of correct decision in phase channel. So this is the probability of wrong decision in phase channel. So what will be the probability of correct decision in phase channel? That will be 1 minus P dash. And exactly that is equal to probability of correct decision in quadriphase channel as well. Okay. So probability of correct decision in phase channel equal to probability of correct decision in quadriphase channel is equal to 1 minus P. Now what will be the probability of correct decision in QPSK? You have two channels, in phase and quadriphase. Each has probability of correct decision which is equal to 1 minus P dash. Then what will be the probability of correct decision in in the entire signal? Okay, in QPSK, that will be simply the product of integer correct decision probabilities, PCI and PQCQ, that's equal to 1 minus P all square. See this, that is, we have these two channels independent, so their probability, joint probability, will be the product of their individual probabilities. So this is the equation and you can write it like this. Okay. Now this is the probability of correct decision in QPSK. Okay. Now what will be the probability of wrong decision or erroneous decision in QPSK? 1 minus probability of correct decision, that is P is equal to this one. Now in the regions where root E by 2 and 0 is very much greater than 1, that is, this is very much greater than 1, you can simply neglect this quadratic term, and then the probability of error in QPSK will be equal to complementary error function of root E by 2 n0. So this is the probability of error in QPSK modulation scheme. Thank you.